This is America in Space, a weekly news and information program on current events dealing with the space industry.
Welcome, and thanks for joining me today. I'm Dawn Meyer, Space Coast News Editor. Well, Crew 3 has a lot of scientific research and experiments planned for the 6 months that they're going to be aboard the space station. The Dragon capsule is carrying over 150 pounds of supplies and equipment that they will be using to conduct experiments. Now, some of that research that's riding with them into low Earth orbit includes the Smartphone Video Guidance System, or SVGS, which is a project that's a collaboration between NASA's Marshall Space Flight Center in Huntsville, Alabama, and the Florida Institute of Technology in Melbourne, Florida. The system uses advanced sensors designed for automated rendezvous and capture of spacecraft. It will be deployed and tested using the station's AstroBee facility, which uses free-flying robots to test new technology and software. If it is successful, the software could enable future use in multi-spacecraft formations of CubeSats and other small satellites that will demonstrate the technology's potential advantages in other robotic proximity operations such as rendezvous and docking. Now, in addition, Crew Dragon is carrying resupply hardware for the Food Physiology Study and Investigation, which documents if the effects of the dietary improvements that are made will also improve immune function and gut microbes to help the crew better adapt to spaceflight. An enhanced understanding of food's effects on physiology and microgravity can help scientists continue to improve spaceflight diet and crew health. Then the crew will also be collecting biological samples to provide data to scientists back on the ground to continue to study how the dietary changes affect living in microgravity. The Uniform Protein Crystal Growth, or UPCG, is also launching aboard Crew 3. This study aims to leverage microgravity to grow a batch of near-perfect nanocrystals of riboswitch RNA, which is responsible for switching individual genes on and off. Once the crystals are grown and returned aboard a different Crew Dragon spacecraft, researchers plan to quickly analyze the nanocrystals using what's called the X-ray free electron laser, or XFEL, which is a powerful atomic imaging technology that allows the users to create a movie of the structural changes taking place during critical processes that may only last a couple of milliseconds. So this process hasn't been able to be observed due to the inability to grow large enough crystals on the ground. So findings could help researchers better understand the process of gene switching as well as advance the XFEL technology itself, which has potential applications in biotechnology and medicine. Now, in addition to those experiments that are flying with them, the astronauts are scheduled to conduct many additional experiments and technology demonstrations during their mission. These are going to include testing the upgrades of the space station's environmental control and life system, including the newly installed toilet, the brine processing assembly, carbon dioxide scrubbers, and 2 new hydrogen sensors that are slated to arrive in December. They also plan to test the printing of fiber optics and a handheld bioprinter to study concrete hardening among some of the more than 200 investigations during their time in orbit. So they're going to be kept quite busy over the next 6 months. From Florida Space Coast, this is Dawn Meyer for About Space Today.
Thanks for listening. Be sure to share our program with your family and friends and follow us on Facebook. Join us each week for news and information on America in Space.